Hello everyone. In today's lecture, we will see some more practice questions based on applications of derivative. So let's start. Practice questions from 37 to 40. In the last class, we have discussed till question number 36. We have seen a lot of different types of questions, right? So in this lecture also, we will see some more types of questions based on applications of derivatives. Okay, let's start. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Okay, let's start with question number 37, which says, if fx satisfies the conditions of Rolle's theorem in 3 to 5, then integration of 3 to 5 fx dx is equal to, right? So fx is given, the hint of this question is see, fx is given such that it is satisfying Rolle's theorem, right? In the interval 3 to 5. Then you have to calculate the value of integration of 3 to 5 fx dx. So what were the conditions of Rolle's theorem? The condition 1 was the function should be continuous in the closed interval 3 to 5, right? The second condition for Rolle's theorem that the function should be differentiable in open interval 3 to 5. And the third condition is fa is equal to fb. Then there exists at least one c such that f dash c is equal to 0. This is the condition of Rolle's theorem, right? Clear? So with this approach, you can go with this question. Okay. So you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. Since fx satisfies all the conditions of Rolle's theorem in 3 to 5, therefore fx can be written as x minus 3 into x minus 5, x minus 3 into x minus 5, right? Because f of 3 should be equal to f of 5, right? Now it has become quadratic equation, and it can be written like x square minus 8x plus 15. Now integration of 3 to 5 fx dx can be written as integration of 3 to 5 x square minus 8x plus 15. See, x square minus 8x plus 15 dx, clear? And after integrating this thing, this expression you will get x cube by 3 minus 8x square by 2 plus 15x, and limit is from 3 to 5, clear? After putting the values, you will get 125 upon 3 minus 100 plus 75 minus 9 minus 36 plus 45. So you will get 50 upon 3 minus 13, which is equal to minus 4 by 3, clear? So I think option D is the right choice, minus 4 by 3. Clear? D is the right choice, minus 4 by 3. Got it? Okay, let's move to the next question. Question number 38, which says a value of c for which the equation for which the conclusion of mean value theorem holds for the function fx equal to log ex on the interval 1 to 3. Clear? Again, c. It has been asked the value of c. So the hint of this question is c. Since fx equal to log ex is satisfying the conditions of mean value theorem, right? Satisfying the conditions of mean value theorem. So again, the statements of mean value theorem was the functions would be continuous in closed interval a to b. The function should be differentiable in open interval a to b. Right? Then there must be at least one c such that f dash c is equal to fb minus fa upon b minus a. Right? So this was the conditions of basically mean value theorem. Clear? So by this way you can approach this question. Clear? You have 10 seconds to solve this question. After 10 seconds we will discuss the solution. Okay, let's move to the solution part C. As we know that using mean value theorem, f dash c is equal to f3 minus f1 upon 3 minus 1, right? Because there exists at least one c such that f dash c is equal to fb minus fa upon b minus c. Clear? Now see, fx is basically log ex. So fc is log ec. Therefore, f dash c is basically 1 by c. Clear? And f3 is log e3 minus f1 is log e1. We know that log e1 is 0. Clear? So 1 by c is basically log e3 minus log e1 upon b minus 1. b minus a, that is 3 minus 1, so 2. Therefore, after solving, you will get c as 2 upon log e3, which is equal to 2 log 3. Clear? 2 log 3. What is so? I think option A is the right choice. 2 log 3. A is the right choice. Fine. Okay. So let's move to the next question. Question number 39, which says the abscissa of the points of the curve y is equal to x cube in the interval -2 to 2, where the slope of the tangents can be obtained by mean value theorem for the interval -2 to 2 r. Again, see, we have to use mean value theorem. And abscissa of the points of y equal to x cube in the interval -2 to 2, where the slope of tangents can be obtained by the mean value theorem, is basically we have to find. Yeah, we have to find abscissa of this curve. Now, what were the conditions of mean value theorem? As we know, the function should be continuous in between a to b. Yes, y equal to x cube is continuous in -2 to 2. The function should be differentiable in closed interval, open interval -2 to 2. And we can see that the function y equal to x cube is differentiable in -2 to 2. Right? So we can apply the conditions of mean value theorem here. So there must exist at least one c such that f dash c is equal to fb minus fa upon b minus c. So by this approach, you can go to the question. So you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. Given equation of curve is y is equal to x cube is equal to fx. Clear? Now f2 is equal to 8 and f minus 2 is equal to -8, right? By putting the values of 2 and minus. Now f dash x is equal to 3x square. Clear? F dash x is equal to 3x square. Now f dash x can be written as f2 minus f of -2 upon 2 minus -2. Clear? So which can be written as 8 minus -8 upon 4, which is equal to 3 square, right? Therefore, x is basically plus minus 2 by root 3 after solving this. Clear? So by this way, you can apply mean value theorem. Okay. First, you have to check the conditions of mean value theorem. After that, you can apply. So I think option A is the right choice. Plus minus 2 by root 3, right? A is the right choice. Okay. So let's move to the next question. Question number 40, which says, in the mean value theorem, fb minus fa is equal to b minus a f dash c, right? We know this. If a is equal to 4, b is equal to 9, and fx is equal to root x, then the value of c is. We have to find the value of c. So first, the hint of this question is first we will let's check whether the function root x is continuous in 4 to 9 or not, right? So fx equal to root x is continuous in 4 to 9, right? Whether it is differentiable in the interval 4 to 9 or not. Yes. See, root x will not be differentiable at x equal to 0. Clear? But see, from 4 to 9, x equal to 0 is not coming, right? So fx equal to root x is also differentiable in the interval 4 to 9. Also, fa is equal to fa not equal to fb. Clear? Fa not is not equal to fb. So we cannot apply mean value theorem. We cannot apply Rolle's theorem. We have to apply mean value theorem. Clear? So we know that for the mean value theorem, if the conditions will be satisfied, that is the two conditions that I have told you is satisfied, then there exists at least one c such that f dash c is equal to fb minus fa upon b minus a, right? Clear? So condition is satisfying, we can apply mean value theorem. So you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. Since fx is equal to root x, therefore fa is equal to 2 and fb is equal to 3. Now, see, let's calculate f dash x. F dash x is 1 by 2 root x. Clear? So there must exist at least one c such that f dash c is equal to fb minus fa upon b minus a. So fb is 3, fa is 2, and 9 minus 4, which is 1 by 5. So f dash c is 1 by 2 root c. Therefore, 1 by 2 root c is equal to 1 by 5. So c can be written as 25 upon 4, which is basically 6.25. Clear? So answer should be 6.25, right? Okay. So I think option D is the right choice. Option D, 6.25 is the right one. Okay. So in this way, we have seen a lot of questions based on applications of derivatives. Hope you understand the concept of mean value theorem, Lagrange's mean value theorem, and Rose theorem. Clear? So these are basically the questions based on mean value theorem and Rose theorem. Okay. Hope you liked the lecture. Okay. Thank you so much.